Hello, everyone. Upon your request, you asked for a review guide for midterm exam. So here I'm going to go over some of the contents we're going to be tested on the midterm exam. And some of the materials will be covered in next week, week number 7. So we're going to start with the index card because the contents in the index card are really, they are the centerpiece we're going to be testing you guys on. The first 6 index cards, right? Number 1, number 2, number 3, number 4, number 5, number 6. These are basic algebraic mathematical principles. So these are the principles we used before you enter calculus class. So you should know these principles very well. And I know you do, but these principles are used over and over again in calculus. Okay, so now the first thing, the concept of limits. Limits is the first important concept of this course. Okay, of course, you need to know the definition and how do we apply the definition. As we went over the examples in the textbook, examples and lectures, lessons, we talk about many times how the limit, the definition of limit implies. It does not require the function to be defined at a when we discuss the limit when x approaches a. And that is a very, very important thing that we need to understand. And also that when can we do direct substitution? And of course, later, once we learn continuity, we know that, polynomials, and all the functions we have learned before, they are all continuous in their domains. Of course, that comes right after this. One-sided limit. Okay, one-sided limit is very important, and because it is involved in this theorem. Okay, so that's why you see on the first question, this is a review, the first question I have here. This is a familiar question we have in our homework, and you've been quizzed before, right? So in this question, what are we quizzing you on? What are we quizzing you on is about one-sided limit and the theorem, right? You have, of course, the solution to this question, but in addition to this one-sided limit, and also this theorem, we also will have additional question for you because about continuity, right? So this part was not a quiz on you. So let's fast forward, right, to continuity. Continuous functions, right? So let's move on to continuity. Continuity, of course, we have 3 elements in continuity, right? So when you're going to have a question similar to this. It may not be exactly the same, but on top of knowing the one-sided limit and that theorem for limit to exist, and you will also need to answer the question about the continuity of this function. So this will require you to make a connection between limit and continuity, one-sided limit as how it is related to continuity, and continuous interval, right? So these are tested. So you'll be giving the interval where the function is continuous. So in that case, you're going to be applying these theorems, right? These theorems about these specific functions. For example, trig functions are continuous. in its domain, and or other functions, and you get to apply this theorem in order to answer this question. And what are the points that may or may not be continuous, right? So you will come up with like the interval is, it could be open, it will be closed, right? So this other definition will also be used, right? Left continuous, right continuous. You know what I mean, right? For example, in this question, we are familiar with the function that is, this function is, has limit, right? This function has limit. We've done this question before. Left limit, right limit are the same, so limit exists. And the function value at 0 also exists. And now you're going to compare the limit with the definition of the function to answer the question whether it is continuous. And that also will answer the question that is the function continuous at 0, right? And how you're going to express the interval, okay? So I'm not going to give you the exact answer as now, because this is not about solution. This is about how this test is related and what are the concepts that will be tested, okay? So the concepts that are tested, for me, to prepare the exam, is my focus is on the contents in the flashcards. And the questions are going to be reflecting that our intention to assess if you understand the concept that we covered, right? So this will require you to apply some of the continuity concept. And also, what's the definition of discontinuity, right? So these will be the additional question you will see on the exam, as in addition to the question you saw on limit, right? In homework number 2, right? You see on homework number 2, right? All of these questions, right? These questions are, in homework set number 2, at that time, we only considered a limit. So now after we have studied continuity, so we're gonna make a connection with the continuity. Okay, so that's the first question, or the first type of question about limits. Second question, the second question I indicated here is that there are 3 places, or maybe more than 3 places, actually more than 3 places, 4 places, okay, that we have limit issue. So we're gonna cover those. The first place is in homework set number 1, homework set number 2, right? I selected the first question. So all of these questions, they all apply the definition of limits, right? So you should know each one of those. There are, in general, 3 types. 3 types algebraically. Let me think. Is it 3 types? If we have more, then we have more types, right? The 3 types, I mean, one is this type, right? This question, that's one type. And the other type would be, so the first type would be the rational function, right? Rational function is one type. The second type is complex fraction. That's another type. And the third kind is root function. Okay, so these are the 3 major types, right? Rational function type will be this one, this one, this one. These are rational types, okay? The first 6 questions are the rational type. Number 12 is rational type. 11. Complex fraction. Okay, so let me circle that, right? So these are the rational function types, right? 1 to 6. These are the rational function type. Complex fraction is this type. That's a complex fraction type. Okay? These are complex fraction type. These are complex fraction type. You see what I meant? Root function type. Okay, so these are both, right? This has a root, and these are the roots, right? So root function type. So these are the three major algebraic types in this category. So I put this question here. This is just one of the three types. So you need to know how to do the other two types. Okay, the other two types. So like you have done the homework, so it's just time to review. Okay. Now, second question I have. Okay, so let me clean this up. Clear all drawings, right? The next one will be, you can see this is the trigonometry. This is related to the two special trig limits. Okay, this is two special trig limits. These questions will be on your exam trig. Okay, and we have lessons. Okay, we have lessons. We talk about we have that part, and the homework. The similar questions show up in homework number 5. So let me take you there. Homework set number 5. So this is just one of the examples. I picked the first one. I'm sorry, the second one. Sorry. Where's my, okay, let me move this guy over here, right? Not this one anymore. So this is the second question in the homework. So it's been chosen among these questions. Okay, we're not going to do the even number, we just do the odd numbers. Okay, so you should be able to do all the others. Okay, 39, you should know how to do it. And I've covered some of these even numbers. Okay, maybe there are candidates for extra credit. Okay, I have not prepared for extra credit questions, but if you ask for extra credit, well, it should require some extra effort. Okay, so a question will be selected from here on your midterm exam. Okay, all right. So we have those review materials that you can start preparing. All right. The third limit, you see, each limit I have chosen to put on the test is very specific because I cannot, the test has to be short enough, but not too long, right? And long enough and short enough. So the third question is covering homework number 2. Okay, so we're going to go back to homework number 2. We were there before. So this type of question, I just choose one of them, right? Absolute value type. So the question I have selected are from here. Okay, both even and odd are included. So I'm going to select a question from here, and this is the other one, right? So how many questions are there? 7, right? We've done them all in class. or in the recorded lessons, right? In the recorded lessons. All right. And of course, number 8 was mentioned in the previous setting, Okay. Right? So you got it. So the limit types, 1, 2, 3. You can see each question represents a category of limits, right? They are covered at different times of the semester, right? The trig, 2 special trig limit was covered a little bit later, but I brought them over here. The third topics would be squeeze theorem. Squeeze theorem, that are similar questions in homework number 3. So let's go through homework number 3. Okay, right here. I selected number 6. Number 6 was selected. We only have a total of 7 questions, and we have done them all in the recorded lessons and in the classes, in the classroom, right? So you just need to know and review all of these questions, and some of these are on the quizzes. So when you review, make sure you go back to the quizzes and look at my corrections. If you didn't do them perfectly, you know, there are solutions being posted that you should study them. Make sure the questions that were tested in the quizzes should be corrected and done properly. If you have any questions, please reach out to me. Okay, so that's about squeeze theorem. Now, we talk about 3 limits, right? The 3 different types of limit. The fourth one is limit at infinity and the vertical asymptote You're looking at question number 4. We're looking at question number 4. Okay, so let's do this one by one. The first one, similar questions you're going to see in homework number 4. Okay, these are related to limit at infinity. We have done all of these questions one by one. I remember in class and in our lessons. You know, this question I put it here because I did it in my lessons. I remember that very clearly. This, even though it was an even number, okay. I will, and this question, it was covered by one of my lessons. You know, for there are 2 lessons on limit at infinity and A, B in a week. So I put this here. You should know how to do it. Similar question we did in class. Okay, we did it in class. I typically did all 3 of them. We did all 3 of them. And one of them were quizzed on you before, right? This one was quizzed on you before, this one. And the other 2, no, this one was quizzed before, sorry. That one was quizzed before. You should know how to do it. What if I put it on the text again, right? Do not assume what's been quizzed and tested before will not be covered again. Okay? Because I wanted to touch on those important points. And number 1, number 2, right? Number 1, number 2. So here is what. These questions are, you know, I would say the 4 types. Okay, limit at infinity, right? And keep going. These questions involves another important continuous function property, which I talked about earlier, this one and the next one, okay, which is a composition of continuous function, right? Especially this one. It's used over and over again, or used over and over again. I remember talking about them in class, very specifically, and in my lessons, I talk about these two very specifically. These two properties are super duper important, super duper important. So be aware that we're using them. So some of these examples about that. And 1, 2, number 1, number 2. So once again, limit at infinity. We also have, I would say, these types, okay? These types. What are the types, right? The first type is just rational functions, similar to that, okay? Rational functions. Okay, I show you the copy and paste so you know that there are some similarities. Rational functions, so all of these are rational functions. And root functions, I think we just don't have complex fraction, okay? We just don't have complex fraction. But we have logarithm, right? These two questions we did in class, right? So these are the three types. So talking about limit at infinity, and this question, right here, right? This question number 2, right here, you see I chose the harder one, negative infinity, right? And there's some positive infinity. This number 28 was the one I've chosen, right? And the 27, you should know how to do it. And the one we chosen, let's see, earlier, right? Where was it? This one, 24, right? 24, 23, 24, and keep going, right? And these we covered in class. These questions we covered in class. The ones I covered in class, you need to know how to do them. And you, from our past quizzes, you understand it's not automatic. Just because I did it in class, you automatically know how to do it. You have to get your hands on it and really, really do it, and can do it independently by you. And because you'll be doing these questions, you'll be working on your exams independently by yourself. Okay, so limit at infinity, that's a big category. That's a big category. Okay, number 37, you should know how to do it, right? All right. The third question is actually related to some homeworks in homework number 4. Homework number 4. So let's look at homework number 4. No, I'm sorry, number 2. My bad. Homework number 2. Infinite limit. I just choose one of them. Okay. All of these doesn't have a limit, but how do we analyze? Is it approaching negative infinity, positive infinity, and how do we analyze it? So this is one of the questions. I think on one of the quizzes I gave to students who are taking the makeup quiz. Okay, but the way to analyze it is something you need to learn how to do. Okay. All right. So keep going. Intermediate value theorem. Intermediate value theorem, right? That there's number of questions on the homework. We did most of them. How many questions? 1, 2, 3, 4, 5, 6. So one of the 6 questions will be selected. So we don't have a whole lot of choices, right? And how to apply intermediate value theorem? We have at least 2 recordings about how to do it. Okay, how do we quote the theorem? How do we check the conditions? And we didn't have 8 questions. We just have, no, just 6 questions. 6 questions. You should know how to do each one of them. All right. So intermediate value theorem. There's a question on intermediate value theorem. Don't worry about the points because I haven't decided on the points. All right. Intermediate value theorem. And next comes to the definition of a derivative. Definition of derivative. Definition of derivative, that's homework number 4. So since then, we've been covering the limit laws, derivative rules, the rules of derivative, right? But before that, there will be a question on the exam as how to find a derivative, right? So we have all these different types of, on derivative, how to find the derivative, how to find tangent lines. And the tangent line question comes next. But let's look at question number 6, right, on this title. Okay, so once again, there are 3, I think there are 3 types. Yeah, there are 3 types again. To apply the definition of derivative to functions. What are the first type? Okay, so I'm going to copy that one more time. Okay, and make changes. I'm going to make changes. Okay, 3 types. 3 types you need to know. The first type, rational function, right? So this is a rational function. If you're given a rational function, can you find the, right, that's a rational function. Rational function such as this, right? Rational function and rational functions, right? Apply definition of derivative to rational functions. Root functions. Root functions. So this one is both, right? This is both. And do we have a complex function? No, we actually don't have a complex function. Lucky us. We don't have a complex function. That's good news. But we do have a third type. The third type is the easiest type. Polynomial. Polynomials. So what are the polynomials? The polynomials are, this one, right? That's a polynomial. Okay, you see many different examples, and you should know how to do these, how to find the slope, but we will also know how to find slope by taking derivative, right? So in terms of question number 6, you need to know how to do 3 types: rational function, root function, polynomial. I give you rational function as an example. And on the exam, it could be a root function, it could be a polynomial function, it could be a rational function. It could be one of the 3 kinds. One of the 3 kinds. All right. So let's move forward. And then we enter the arena of derivative. We enter the arena of derivative, so let's go to homework number 5. Homework number 5. Derivative, right? In these sections, as I told you, I will be choosing questions from odd number, 3, 5, right? Odd number, right? Even number optional. And what are we testing you guys on, right? Odd number. What are we testing you on? Derivative rules. I just randomly picked these questions, okay? And they're different from the question on the exam, but there could be some similarities. I'm not saying whatever question I picked for this, then those are not going to be tested. I did not say that. You should know how to do them anyway. All right. So what are these derivative rules, right? So let's go back to our flashcards, right? I didn't talk about limit laws. Limit laws being talked about so many times, right? So these properties, and there's 3 types. I chose 3 types. The first types are number 7, right? Laws of derivative, right? Laws of derivative here, because you're going to be dealing adding, subtracting, multiplying, dividing, product rule, quotient rule, chain rule. And you definitively should know how to do them, right? Laws of derivative. And the derivative e to the power x, you see there's a product rule, quotient rule. And these are the derivative rules, right? Laws of derivatives. And these 3 questions I just randomly chose from here, from your homework. You should know how to do them, right? And practice them more. And there will also be types that you need to apply chain rule and other rules. And trig function, right? So these derivatives, you need to know not only, there will also be some types you need to know, you need to deal with, okay? Rational functions, root functions, polynomials. You know how to do derivative for these, and also exponential functions. Right? What else? Trig functions. Functions derivatives, right? So this you can see involve exponential function, rational function, polynomials, that which is the simplest, and trig functions. Okay, and also finding tangent line. We've done some examples in class. So find an equation of tangent line to the curve at a given point. So you need to know how to do these by finding the derivative, and then find the tangent, find the slope, and then find the line equation, right? So you find the slope of tangent line by taking derivative. Slope of the tangent line by derivative. Or derivative function. By derivative function. Number 9, you see number 8 is number 7, derivative. Number 8 is about derivative and tangent line. Number 9 is more on chain rule and other rules. So chain rule and other rules. So this will take us to homework number 6. okay, chain rule and other rules. So the question I've chosen here are randomly chosen from your homework here. In this part, I'll be choosing from the odd number. I'll be choosing from the odd number, okay? Now, there are 2 more questions on the exam without extra credit, okay? Implicit differentiation and logarithm differentiation. Implicit differentiation, there will be 1 question on implicit differentiation. We did the first one, number 5. I think we did one of this, number 5 or number 7, I forgot. And so we're going to choose from one of these odd numbers. Okay, one of the odd numbers. Hold on. There. Okay. So I'm going to choose from one of the odd numbers. Implicit differentiation. Implicit differentiation, number 10. We're going to do more on Monday. Okay. And logarithm differentiation. We have not covered that in class yet. But I'm going to tell you where to find them. That's going to be homework week number 7, which is next week, right? It's coming. So this week, well, I already opened up the implicit differentiation for you to work with. Homework number 7, logarithm differentiation. Okay, so there will be the last question on the exam is logarithmic differentiation. Okay, which is chosen from homework number 7. And of course, at that time, when we cover it, my plan is to choose these odd numbers. Odd numbers, okay, oops, okay, choose from these odd numbers. We're gonna choose some from here. And choose some from here, okay? That's it. That's a 100 points. The points assignment, because I have not completely ready for the midterm exam, and so, and there are uncovered materials that we'll cover next week on week number 7. So I'll give you more information. Actually, these should be included as well. These should be included. You know what? I'm going to include all of these because there are not that many questions. Okay, so the question number 7, we're going to cover next week. We'll be including those. Okay. All right. So that's the review guide. That's the review guide. Okay. Thank you for watching.